Hi guys, I'm sorry I haven't been able to be there in person. I've been a little bit under the weather and I haven't quite gotten back to where I want to be. But today I wanted to try something a little different and pre-record what I would have covered in class with you today. I wanted to begin with a brief chat about what it was that you all covered, not just the last class with me, but also the last class with on your own with a sub. We already started a key WL chart, so remember that that's the poster, that green poster, that shows K for what we know, W for what we want to know, and L for what we learned, which we'll fill out at the end. We filled out what we knew about maps, and hopefully as the unit continues and you learn a little bit more, maybe some more questions will arise that we can put on that middle section of the poster, and we can answer for you as we continue our learning. So definitely always feel free to add any questions to that green map, or to the green KWL chart if you'd like, and maybe we can address them as we go along. We've covered some basic definitions, which you should all have on your Google Doc to refer to. Remember, if you prefer to have printed notes, you can visit the library and print them there for free. Or you can always just have them on your Google Drive for reference as well. The worksheet, I understand that the worksheet from Wednesday probably seemed a little repetitive with the definitions again, but these terms are ones we will use a lot in this short and sweet unit on mapping and topographic maps. The last slideshow also covered 4 different ways to show elevation. Hopefully these sound a little familiar to you. So the way that we can show elevation on maps are through contour lines, color coding, shaded relief, and spot elevation. We also covered why contour lines don't intersect, since all points along the lines refer to the same elevation, and how the only time that contour lines may look as if they're touching is if it's a very steep hill. So just always remember that contour lines on a topographic map that are very close together usually indicate a very steep hill. The slideshow also covered some scales. So I wanted to bring up another picture, one that you guys hadn't seen yet, but let's just hash it back to, or start back at the definition of scale, which is a ratio of an image on a map to the real world. There's 3 types of scales: verbal, fractional, and graphic. But I wanted to talk about fractional scales using model cards, just because this is honestly one of the easiest ways to think about it sometimes. So if you look at the toy cars, the biggest has a 1 to 18 scale. So that means for every inch on this model car, so the 1 to 18 scale, the brown car, so for every inch on that brown model car, it represents 18 inches of the real thing. The convertible car next to it, the 1 to 24 scale, basically means that for every inch on that 1 to 24 scale, for every inch of that model, it represents 24 inches on the real car. And it keeps going with the smaller cars, but you notice that basically we are losing details with the smaller scale, or smaller fractional scales. So another way that you can look at this is by looking at the scale, or looking at this slide, and this slide was directly from our last slideshow. So basically, the larger scale versus small scale. The smallest scale is the 1 to 100,000, and the largest is being the 1 to 2,500. You kind of want to look at it, or the way that I see it is kind of, you're almost zooming in and zooming out, but a smaller scale covers large area but with a lot less detail, and the large scale covers less area or small area but with more detail. Hence, large scales equals small area and more detail. So you just kind of try to remember which one, that the smaller scale is large area, less detail, larger scale, small area, it's more detail though. The next slide is from an image on your topographic map worksheet that you had on the last class. And so I wanted to quickly review some of the steps that you had to take to answer those questions. I will tell you that typically contour intervals are given on maps, but for this class, we just want to make it a little bit harder and make sure that you guys know how to actually find the contour intervals. But it really is pretty simple when you break it down. So the way that, let me back up. So although we have 4 questions to answer here, it is helpful to start by finding the contour interval. So the way that you do this is use what you already have. So we need to find 2 contour lines that are marked and find the difference between. So what I did was I looked at and found 4400 and I see 4340. So I saw that there's a total difference of 4 lines between these contour intervals or contour lines, excuse me. So to find the contour interval, I subtracted 4340 from 4400, so that gives me 60, and I divided by 4 since I have my 4 lines, which equals 20. So I've learned that I have a 20-foot contour interval between each lines, and you can always go back and double check yourself. So I know that this is 4340, so 43.8, 60, 43.80, and then 4400, so that I know that my contour interval is correct. Then the question asks, what is the relief from the parking area to the peak elevation? So again, I want to start with what I have, or what I already know. I found the parking area and saw that there is a contour line right here in the middle. It kind of goes right there, but of course, nothing's going to be easy for us, and the contour interval doesn't have an elevation. So I found the closest one that did have it, and I pointed that blue arrow over here, so 4300. We know that that's the elevation for this contour interval. So working backwards, now that we know the contour interval of 20, we can assume, or we know that the elevation is 4280. So we know that that relief is just the difference between the highest and the lowest point. So all we have to do is subtract that 4280 from 5117, or 5117, which gives us a relief of 837 feet. So that means that when you're walking from this parking area all the way back up to the peak, the difference in height of where you're standing is a total of 837 feet, which is pretty high. So you gotta be kind of brave to climb those high peaks. Next, I wanted to talk about gradient or slope. Basically, this is just rise over run. So it gives us the change in elevation over a certain distance. So right here, our example would be 20 meters over 5 kilometers, and that is your gradient or slope. So I just wanted to revisit that so that you have a little bit of a refresher. So next, it's your turn to practice. On your agenda in Google Classroom, you have a geology website, which you are more than welcome to use as practice. This is a great practice website if you are still unsure of how to figure out elevations and contour intervals, and just practice and check yourself and make sure that you know how to do it. So I've only asked you to do a couple of questions, I believe about 14 or so. So if you could just write your answers down on your agenda, that way I can see that you've done the work. You can also work on interpreting contour map worksheets. These worksheets also include at the bottom practice drawing topographic profiles. So remember that topographic profiles are basically just showing the topographic map on a graph and showing the different elevations. So you are more than welcome to collaborate. You know that I'm very happy when you guys collaborate. And whatever is not finished for class, you can finish for homework. And hopefully I will see you next class. All right, thank you. Bye. And happy Friday. Have a good weekend.